What is robotics? Yes, indeed. So thanks for the opportunity to speak. I think there are many terms and phrases that are used within the kind of broad scope of robotics and AI, machine learning, deep learning, cognitive computing, etc. But trying to distill it down, I think at the end of the day, it's trying to use technology and neural networks and those kinds of capabilities in order to mimic what the human brain does typically pretty well. And obviously the state of those technologies have matured a lot of recent times. You know, we've gone from doing things that most of us can do pretty well, like recognize what a cat is, to things which most of us can't do very well, like beating Kasparov at chess, or the recent news in terms of beating the world's Go champion, for example. And also being able to do it faster, without error, 24/7, etc., which is obviously moving into what the capabilities of robotics are all about. So to do these kinds of technologies had impact, I would argue they certainly do. So that some of the work that we've done, for example, in the field of medicine, it takes around 160 hours every week to read all the medical literature that exists in the world coming out over that week. And as you can imagine, that means that doctors and surgeons have no way of actually keeping abreast of all the new information research that comes out on a daily basis. And that has an impact in terms of the healthcare that we all rely on, to the extent that now cognitive computing can now get up to accuracy rates in terms of diagnosing lung cancer at the rate of 90% as opposed to the 50% that humans are able to do. So clearly in industries such as medicine, it's had a profound impact, and I think just by the show of hands, we're probably at the early days still in terms of where robotics and cognitive may have an impact as far as financial services are concerned. But certainly in my experience, there are many robotics projects going on at the moment. Some of them have delivered. Some of them are still on the early stages of that, but we're still a little way off, I think, in terms of really getting the benefits of the technology in terms of what the cognitive and machine learning capabilities really are. So how does it potentially apply to financial services? I would try and keep it relatively simple. There are three kinds of main steps of progression I think we're seeing at the moment. The kind of desktop automation, many people are familiar with. It's relatively old technology, being able to screen scrape and basically automate at the desktop, if you like. This has been around for ages and does very simplistic kind of levels of automation. The current bulk of activity, I would say, I'm not sure we'll comment on this, is around RPA, robotics, process automation. Many tools out there like Autonomy, Blue Prism and others that are capable of providing the right level of automation. Essentially, at the end of the day, they're rules-based. They have advantages of being able to work 24/7, be very scalable, but essentially rules-based. And what the future is bringing the cognitive and deep learning capabilities together in what you might call cognitive operations, where you're then bringing reasoning into the way that automation is done. Automation, being able to diagnose, being able to self-learn, improve all the time. And if you can imagine where that goes, especially being able to understand unstructured information, being able to read, be able to interpret video signals, whatever it may be, there's a whole range of capabilities that you can then apply if you fully bring AI into the operations world as well. So I think there's a huge amount of potential on that latter category. But obviously, there's a lot of short-term benefits to be had from the RPA world, which I think is what we're seeing at the moment.
Thank you. So Terry, your firm's been working in this space for a number of years. You've already been working with a number of financial services clients. Can you give us a feel for what sort of type of projects that you've been working on, what sort of benefits that the clients can see from using robotics?
Yeah, sure. So just to give a bit of background for those that aren't familiar with Autonomy, which I'd imagine is pretty much everybody, we are an early stage UK-based but globally operating technology business, and we have a platform that we call the Virtual Workforce. It's an intelligent automation software as a service, and the concept really is aimed at improving the productivity of human workforces by replicating the way people work in existing business systems and applications in order to either augment human resources or to replace them and allow those human resources to go and do more productive work and hopefully reduce the cost per trade that Keith mentioned earlier, among other things. So that's the platform. There's a number of elements within it. At its core, I guess, is the concept of robotic automation, which, as Keith mentioned, is a piece of software driving those business systems and applications exactly the same way a human would, using a set of structured rules. So I click here, I read what's presented to me, I make a decision based on what I see or what I interpret, I follow some rules to carry out and execute a task. And I'm sure you can all think of many, many examples where you have people doing that kind of rote point, click, drag, drop, retype type activities in your businesses. So that's fairly straightforward and standard robotic execution. If you add into that the elements of cognitive and intelligence or AI, using whatever language is in vogue at the moment, that's about understanding what needs doing so that you can then do it. So if the robot is doing the work, it doesn't know what to do because it's based on a series of rules. It knows which rules to follow, but the elements of intelligence and cognitive is about being able to interpret what am I being required to do, either by extracting data from an unstructured means, like a document or a form or an email, or by conversing in natural language using a chat agent to be able to understand who are you, what do you want me to do, and then pass that work over to a robotic agent to execute it. So that's the core principles of the kind of things we're engaged in. In a financial services context, that tends to be, I should probably just give a little bit of backdrop of the way that we approach these kind of engagements and the way that we've approached delivering this platform to the market is not to deliver huge large-scale transformation, because having spent most of my entire career trying to get people to use technology to transform their businesses, it's actually really difficult. And the difficulty is not the capability of technology, the difficulty is change and transition. So when we approached this platform and this virtual workforce concept, one of the things we were keen to do was make sure it was easy to consume, and it was easy to consume and scale out, and underpinned by some of the technology advances that Keith talked about earlier, the prevalence of enterprise cloud computing that is highly secure, even if you're only using a tiny piece of capacity. Means that you can start very small in a very confident way and scale up very quickly. So we approach things not as a revolution, but almost as an accelerated evolution. Let's take the things that people are doing that cause them pain or cause error or cause problem or would benefit from cost reduction, and let's start a journey of transforming those into automated processes and freeing up the human resource to go do other things. So it's a very long answer, but I'll get there in a minute. In a banking and financial concept, that could be everything from customer onboarding. So we're doing quite a lot around supporting the customer onboarding processes. Again, something I'm sure everybody's familiar with, the number of steps there might be in a customer onboarding process, loading the identity of that person, doing background KYC checks, doing external data validation, making sure you've got all the information to onboard the customer. All of those steps are highly manual, typically, in most organisations, and involve a whole plethora of different underlying systems that might or might not belong to your organisation or to a third party. Really difficult to transform, actually really quite simple to deliver as an automation. So things like KYC checks, things in the front office, customer interaction that takes a request to make a change or an update or a status request, and then support that with the back end. Things in customer onboarding, things in loan application processing. We're doing some work that involves taking a request for a loan, reading information from various forms, doing identity checks, and then processing some background credit analysis that then supports a yes or no decision on a loan. So I'll stop. I'm sure you can think of many in your own businesses that would apply to that kind of the context of people following structured processes driven by some logic, but perhaps some intelligence or some cognitive processing to know what am I being asked to do and then to carry out that task.
Thank you, Terry. Now, a question for you, Keith, at the end there. One thing that Terry hasn't mentioned in his response on use and benefits is robo-advisors, and the trend for investment management now to be formed by a robot rather than an investment manager. Now, some people would say that some of those investment managers were robots anyway, but what do you think is the future, that our money's going to be managed by robots, or is there still space for the individual, the man and the lady, that will make the decisions as to how we invest our futures?
So let me give you full disclosure. I'm on the advisory board of a firm called Forward Lane, which Keith is familiar with. So this is a wealth platform built initially on IBM Watson and substantially moving forward. I'm also on the advisory board of a big simulation startup firm called Simudyne, who's very much the competition to Improbable, who got a load of money last week. So it's a very, very popular area. But I think in terms of first we should reiterate what Keith has said. So we're confusing a bunch of things here, right? So robotics and robo-advice and online voice-activated natural language help desk type stuff is very, very, very different from a true AI model of looking at the markets, right? So if you look at anything to do with money management, wealth, getting people educated is a serious problem. So financial education, even across people who are very, very well educated, is not what it should be. So the whole sort of genesis of the nutmegs and all the way through those sort of guys is a really, really powerful sort of way of moving people along from not really understanding what they should do and taking control. But at the top end of this, what we're really talking about, I think, is there are elements of everything that make up these models, and what Terry's describing is absolutely key, right? Now, the bigger problem, which we should just put on the table before we talk about the new stuff, is we're still in a world where a lot of these very productive things are going on, but we haven't really changed a lot of the crap in the background, right? So we're sort of relayering complexity. Now, the approach to this is quite lightweight. So we're not talking about killing legacy systems. We're talking about isolating, we're building microservices, we're getting data and knowledge and automating that. At the higher end, though, what we're really talking about is it's synthesis, right? So it's synthesis. And one of the ways to articulate it is perhaps we've got a brain and a nervous system, or most of us have. So the thing is all about how those two things collaborate. So if I'm building out digital transformation and analytic capability, I want repeatability as much as I possibly can across any organization. So if I'm New York Police Department doing analytics for crime, or I'm a weather company doing analytics for weather, or I'm the financial services company doing analytics for whatever I'm doing, the infrastructure arguably is predominantly the same architecture, right? Now, that's the nervous system. So that's got to work. It's got to be completely in the background. The brain is really where it gets interesting. So what actually am I trying to synthesize? And in wealth management, there's 2 or 3 different approaches to this. One is very simply a productivity model for the advisor. So can I sell more to more people, or can I actually service more high net worth with much better information? So Keith's analogy on medical advice, can I provide research, timely research, to 50 high net worth as opposed to 10? So if I'm an advisor at Goldman, AIG, anybody, anywhere, can I do more, right? So across the European banking landscape in particular, there's a truckload of money going into re-equipping wealth management. And UBS actually came at it from changing their process first and then relaunching, which wasn't really heavily advertised. So the synthesis piece then comes into, well, what are you really trying to synthesize? And so the devil's in the detail. So unless you've got really good data, reference data, and semantics and ontologies, you can ask something anything. But if it doesn't understand what you're looking for, it's not going to be able to provide you with any differentiated advice, right? So
So data's key is what
yeah. So if you think of how does a fund manager work? Well, a fund manager allocates based on a bunch of factors. Most people have got the same factors. They try and make some differentiated research around those factors. Say there's 50 factors and what's happening today. The opportunity by using really firm, accurate data model-based information and massive data graphs in the background, sort of proper deep learning as opposed to supervised machine learning. So really moving into the depth of correlations and really understanding, then you can imagine you can ask it some very different questions, right?
Just on that point, I think that the most important thing here is that transformation phase, right? Within working for banks and out externally, it's not necessarily building the infrastructure, it's actually taking the cost out of that infrastructure. What you're saying is you're going to have a parallel run of existing infrastructure with this new technology over the top, which is a cost, and the re-engineering of that infrastructure. So where do you get the cost savings eventually over time?
So the cost savings are in improved productivity in a very short space of time. So because what we're deploying is a software agent that emulates a human, none of the underlying systems need to change. So there's no IT project, there's no transformation, there's no coding. There is the development and mapping of a process that a human would follow.
You've already got that infrastructure that you're trying to get the cost out of, which you're kind of liaising with, right?
I understand, but the cost saving we're trying to facilitate in the first phase is not infrastructure or applications, it's people. It's people's time, effort, and potentially improved business performance through in better customer experience, a quicker response to queries, quicker execution of a trade. All of those things will have a business value. So we're not trying to address let's make the infrastructure or applications cheaper. We're trying to address the human productivity. In doing so, you provide a return on investment that frees up time and resources to invest in the transformation activity.
I was going to just follow on the data theme, and I know Keith here mentioned data earlier on in terms of what IBM's Watson is using. What is Watson? And, can Watson do anything and everything? And what's the limits of what Watson can do?
Okay, so Watson is our focus, obviously, in terms of cognitive computing, and it came to the mainstream. As many of you know, I mentioned it earlier, IBM put a lot of effort into chess as a grand challenge, being able to beat the world's top chess player many years ago now, Kasparov at the time. And we set ourselves another major grand challenge, if you like. And these are a very strong and effective process to actually push the boundaries, expand and build new technologies. And the challenge we chose was to beat the best human player of Jeopardy. Now, some of you may not have seen Jeopardy, or you may not be familiar with it, but you can catch up on the detail on YouTube to see the challenge. But essentially, it's a question and answer quiz, if you like, but you're given the answer and have to infer what the question was. The human players are extremely fast, extremely knowledgeable, and essentially what we set up now 4 or 5 years ago, I think, was a challenge that was televised at the time to be able to do that. And essentially it means in real time being able to understand the question, interpret it, work out all the possible answers, and be able to answer the question in the context that it's being asked. And essentially it means having real-time access to the whole of Wikipedia and all the other technologies out there without having access to the internet, which is essentially what it did. So that Watson won the challenge. It's quite an interesting story if you want to catch up on YouTube as to how it was done. And since that time, medicine was the first area we focused on building those capabilities into to really solve real industry challenges, so like the one I mentioned earlier. And the second major focus industry for us is within financial services. So as Keith mentioned, we're working in the kind of wealth advisor space. We're working on the RegTech space in terms of being able to read, digest, understand regulation and the impact it will have and all systems that are needed, etc. We're using it to read syndicated lending documentation, for example. So not only do you just read a standard form, but you can actually read and understand jurisdiction, tax implications, all the sort of things that you would need today a human to do. The technology is now capable of having that level of insight and understanding in those kinds of complex and structured information. So there are many different kinds of use cases that we're seeing. But this is now no longer a big computer that you buy, just consistent with the themes that Keith was talking about earlier. It's essentially available as APIs. So you just go onto a cloud-based environment as a fintech, as a bank, anyone, and just being able to start playing with the various APIs that are there to go from speech to text, text to speech, to understand tone of language, for example, to understand many different kind of emotional analysis. You can look at people's written speeches, tweets, whatever it may be, and do psycholinguistic analysis to do a character profile. There's a whole range of different things that you can do delivered by those APIs that you can just integrate into your own technologies or any others. So that's cognitive in the broad sense. And as I said, we're seeing that apply to do the next stage, if you like, following the rules-based automation that we've talked about earlier in the RPA context. To start bringing in unstructured information and other kind of insight and knowledge to drive better quality decisions, to go even further beyond what the current RPA technologies can do.
Brilliant, thank you. So we've got about 10 minutes to go. I've got further questions, but if anybody from the audience wants to ask any questions at this stage, I'm happy to take questions for the panel.
It's probably a very basic, it's like a terminology thing, it's not just this panel's topic, but there's lots of stuff in the press, lots of panels all talking about robots and robotics. But in actual fact, all you're talking about is software and artificial intelligence or machine learning, etc. A robot is a machine which emulates or improves on human capabilities. So when you're doing chess with Watson or whatever it was, Deep Blue or whatever it was, that if there was an arm that was physically moving the chess pieces driven by that software, it would be a robot. Without the arm doing it, it's not a robot. So why do we keep talking about robots? It's just software. It might be intelligent software, but it's not a robot.
It's a very fair point. People love technology. So terminology, sorry, people love terminology, don't they? I mean, cloud computing is not a cloud. It's a terminology to conjure up an image of stuff that's out there in the ether that you can access and consume. Robotic software is not a robot. It's not a physical machine that's doing anything, but it helps you to, that personification helps you to understand actually it's just robotically replicating what a human would do. So it gives some context rather than just saying it's software.
When it comes to things like, the term robo-advisors, I hear used all the time. Now, I don't know if anybody else around here has an Amazon Echo. I have one, and I thought that's going to be brilliant. I can ask it anything. It's got the entire power of Google and its cloud and everything. It's absolutely fine, as long as you ask it what it knows. So a good example was, just after I bought it, I thought, I'll ask it when the next Ireland Six Nations game is. It went, sorry, I don't understand. I kept saying, Six Nations rugby. I don't understand. I said, when are the New York Yankees playing? And it went, New York Yankees are playing. I went, Alexa, what is rugby? I went, rugby is a game of. And then I repeated, tell me when Ireland are next playing in the Six Nations rugby. And it went, I don't understand. I mean, that's one of the most powerful. Yeah, maybe. But,
That was the issue.
So, and I'm sure everybody has had issues, if you have Sky and you go on to try and call them, it's a robot advisor that's going, how can I help you? Have you had a problem with your installation? Yes. What's wrong with it? You didn't install it. It doesn't understand the concept that it didn't get installed. So how is the industry going to implement something which patently is not achievable given
It's the difference. It's
the vagaries of...
It's the difference between, that's a deterministic Q&A search engine, which has speech capability and recognises something that you're trying to ask it. It isn't anything to do with really going away. And so what Keith did explain, and probably it continues to have to be said, is you've got to train these other systems. So what happens in the background is if you're really building like the forward lane platform, for example, this whole synthesis, as I described the nervous system and the brain, the nervous system is really this process by which you're delivering some sort of information. The brain is learning what are the correlations going on in the background. So how do I switch between questions? And the system learns over time. It won't ever work perfectly on day one, but you've got to feed it with the right stuff. So there is a real obvious problem, which is an industry we struggle with, which is data certainty, process certainty, standards, interoperability, the whole thing. So it's all well and good asking a system something, but it's a bit like, I think Terry would agree. I mean, you can do lots of stuff robotically, but if actually the system goes to find, say in trade reporting, so you've got an exception in the middle office, it's all well and good being automated, but if it still goes and finds crap, it's still crap. So if your counterparty data is incorrect, if your product data is incorrect, if all the data is incorrect in the first place, you can automate the hell out of it, but it won't make a lot of difference. So there's this sort of undercurrent of things that need to get done. And if you look at why cloud works now, and actually why the internet works, so there's always a religion, there's always TCP/IP versus something else, there's always cloud stack, one technology versus another, there's different versions of Hadoop, there's different versions of Linux, there's always a religious argument, but principally people are traveling in the same direction.
Callum Graham from Advent, SS&C Advent. Paul, your light-hearted comment about KYC for robots, I think has probably a deeper resonance when you look at the fact that legacy software was typically written on the basis that it would be installed inside a secure environment. So inside the software, there is very, very little security. Once you're in and rampaging. And I'm aware that there's a drive to create software that has intra-security, intra-module security, a bit of the same way as I lay you bet going through IBM's offices, you won't just be able to go anywhere you want once you're in the building. You know, there's high security in between. So my question is, in a room full of RPA developers, how much is security and cybersecurity high up on the bill as far as developing versus the latest machine learning, computational theory, et cetera? I mean, when do we suddenly come across fake learning in a computer?
I mean, I can comment on the security stuff. So machine learning is incredibly powerful in cyber and other stuff, because what you're looking for is correlation and patterns. And so that's the basis of most new solutions to certainly the cyber problem are machine learning solutions. The other thing, though, is if you look at, and I'm not a technologist, but I would put forward the point that in order to get around the problems we face, we need to extend what the capability that Terry has, which is very much in, as we've described it, the process, to writing rules within the software. So the current way of hacking and the current way of cyber is all predicated on personal irresponsibility of clicking something you shouldn't, and really, really old, crappy software with backdoors. It's very, very rarely the hardware. So it's the software code that is the problem. So autonomic coding in terms of security will be at the software level, not at the hardware level, is an extension of what we've just started. So I think that's where it's going. But most cyber news, Dark Trace is a very well-known company. There's quite a few of them around. Most of them are doing machine learning and behavioral analysis and looking in real time at multiple impacts of different things going on over different scale.
Okay, I'm sorry, I have to close you off now because we're going to have to go into the coffee break and everything, keep on time. But please help me thank very much the panel.